Welcome to my presentation. I am Sadhan Mandal. My roll number is 2005501 and this is present to my honorable teacher Dr. Arifuzzaman, Assistant Professor, Department of Mechanical Engineering, KUET. My topic is surface processing operations. Now introduction. Surface processes are normally carried out once all manufacturing processes is completed, with exception of heat treatments. Many of these processes are often called finishing process. This is also called surface finishing processes. This is used in industrial process and this is done for the improved appearance, adhesion or wettability, corrosion resistance, chemical resistance, wear resistance, hardness, and to modify electrical conductivity. There are several types of surface processing operations. These are industrial cleaning processes, diffusion and implantation, plating and related processes, conversion coating process, vapor deposition processes, and organic coatings. Now I shall discuss all of these processes. Firstly, industrial cleaning process. This is two types, chemical cleaning methods and mechanical cleaning methods. Chemical cleaning methods usually use chemical to remove unwanted contaminants from the work surface. Mechanical cleaning involves removal of contaminants by different mechanical operations. Chemical cleaning processes are 5 types, that is alkaline cleaning, emulsion cleaning, solvent cleaning, acid cleaning, and ultrasonic cleaning. Now alkaline cleaning. Uses an alkali to remove oil, grease, wax, and various types of particles, that is metal chips, silica, light scale, from a metallic surface. Most widely used industrial cleaning methods. Alkaline solutions include sodium and potassium hydroxide, sodium carbonate, borax. Cleaning methods are basically immersion or spraying, followed by water rinse to remove residue. Now emulsion cleaning. We use suitable emulsifier, that is soap, results in the two-phase cleaning fluid, while in water, which functions by dissolving or emulsifying these oils on the part surface. Used on either metal or non-metallic parts, must be followed by alkaline cleaning to eliminate all residues of the organic solvent prior to plating. Now solvent cleaning. Organic soils such as oil and grease are removed from metallic surface by chemical that dissolves the soils. Common application techniques are hand whipping, immersion, spraying, and vapor degreasing. Vapor degreasing uses hot vapors of chlorinated or fluorinated solvents. Acid cleaning. Acid cleaning, it is mostly used in industrial purposes. It removes oils and light oxides from metal surfaces using acid solutions combined with water miscible solvents, wetting and emulsifying agents. Common application techniques: shocking, spraying, or manual brushing or whipping carried out at ambient or elevated temperatures. Different types of acids are used in acid cleaning, that is nitric acid, phosphoric acid, sulfuric acid, and mostly used hydrochloric acid. Acid pickling. It is used to remove thicker oxide, rust, and scales. Distinction between acid cleaning and acid picking is a matter of degree. This is generally results in some using of the metallic surface which serves to improve organic paint adhesion. Ultrasonic cleaning. This is a highly cleaning method. Mechanical agitation of cleaning fluid by high frequency vibration between 20 to 45 kHz to cause cavitation, formation of lower pressure vapor bubbles that scrub the surface. Combines chemical cleaning and mechanical agitation of the cleaning fluid. Cleaning fluid is generally an aqueous solution containing alkaline detergents, highly effective for removing surface contaminants. Now mechanical cleaning. Mechanical cleaning are basically three types: blast finishing, shot finishing, pinning, and mass finishing process. Physical removal of soils, scales, or films from the work surface by abrasive or similar mechanical action often serves other functions also, such as deburring, improving surface finish, and surface hardening. Blast finishing. Done by high velocity impact particulate to clean surface. Media is propelled at the target surface by pressurized air or centrifugal force. Most well-known method is sandblasting, which uses darts of sand as blasting media. Other blasting media, ammonia, and soft media such as 9-hole beds. Shot pinning. This is mechanical cleaning where small pellets called shots are used in cold working process directed on the surface, induced some compressive stresses into surface layer. Used primarily to improve fatigue strength of metal parts. Purpose is therefore different from blast finishing, although surface cleaning is accomplished as a byproduct of the operation. Mechanical cleaning process are used in large scale by mass finishing. This is tumbling method and vibratory finishing method. Finishing parts is bulked by a mixer action in the container, usually in the presence of an abrasive media. Mixing causes parts to rub against media and each other to achieve desired finishing action. All parts are usually small and therefore uneconomical to finish individually. Now I shall discuss tumbling method. Here a cross-sectional view is shown and this rotation is anti-clockwise. When barrel rotates in anti-clockwise direction, then the particles of this media is upward direction and then it is falling in a downward direction. This has some drawbacks. Slow, noisy, large floor space required here. And the barrel rotation of this system 10 to 15 revolutions per minute. Vibratory finishing. This is nothing but this is a modification of tumbling method. Only the system is vibrating in this process. Vibrating vessel subjects all parts to agitation with the abrasive media as opposed to only the top layer as in barrel finishing Processing times for vibrating finishing are significantly reduced. Open permits inspection of parts during processing and noise is reduced. There are some media, that is alumina, greater consistency, size and shape, hardness. Steel used for surface hardening, varnishing and light deburring operations. Natural media, that is granite, limestone. This is another technique, surface chemistry. Two processes that impregnate the surface of a substrate with foreign atoms, that is diffusion process, and another is ion implantation process. Now I shall discuss ion implantation. In this figure, there are parent crystalline lattice structure and another is modified surface layer and implanted ion which comes to contact with modified surface layer. And here is another figure, implantation process and after implantation process. Embedding atoms of on or foreign elements into a substrate surface using high energy beam of ionized particles results in alteration of the chemistry and physical properties of layer near the substrate surface, produces a much thinner altered layer and different concentration profile than diffusion. Here are some applications of ion implantation: low temperature processing. This is good and reproductivity of impurity, penetration depth, solubility limits can be exceeded without precipitation of excess atoms. It has some applications, fabrication of semiconductor devices. Now plating and other related processes. What is plating? Coating thin metallic layer into surface of a substrate material. Substrate is generally metallic, although methods are available to plate plastic and ceramic parts. Processes: electroplating, electroforming, electroless plating, and hot dipping. I shall discuss here only electroplating and hot dipping. Electroplating. In this figure, here a plating tank, and plating tank contains electrolytic solution and cathode, that is work part, and anode, plating metal. Electrolysis process in which metal ion in an electrolyte solution are deposited onto a cathode work part. This is also called electrochemical plating. Anode is generally made of the plating metal and serves as a source of the plate metal. Direct current from an external power supply is passed between anode and cathode. Electrolyte is an aqueous solution of acid, base or salts. Here, theoretical electroplating equation, we know Faraday laws B = C by T. Here V is volume of metal plated, C plating constant which depends on electrochemical equivalence and density. C indicates the amount of plating material deposited onto cathodic work part per electrical charge. There are some common coating metals, that is zinc, nickel and tin. Zinc plated on steel products such as fastener, wire goods, electric fuse boxes and sheet metal parts as a sacrificial barrier to corrosion. Nickel for corrosion resistance and decorative purposes on steel, brass, zinc, die casting, etc. also used as base coat for chrome plate. Tin. This is widely used for corrosion protection in tin cars and other food containers. Most coating metals are copper, chromium, a precise metal is gold and silver. This is used for jewelry. Gold is also used in electrical contacts. Another process, hot dipping. Hot dipping, most substrate is immersed in a molten bath of second metal. When removed, the second metal is coated onto the first. Common substrate metal, steel and iron. Coating metals, zinc, alumina, tin and lead. Primary purpose is to corrosion protection. There are several types of hot dipping process: galvanizing, galvanizing and tinning. Galvanizing is nothing but coated of zinc onto steel or iron parts. Galvanizing is nothing but coating of alumina onto the substrate. This is the excellent corrosion protection, in some cases 5 times more effective than galvanizing. Tinning, this is nothing but coating of tin onto steel for food containers, dairy equipment, and different types of soldering applications. Now I shall discuss different deposition processes. One is physical vapor deposition and another is chemical vapor deposition. Physical vapor deposition are some family of processes in which a material is converted to its vapor phase in a vacuum chamber and condensed onto substrate surface as a very thin film. Generally, coating metals are alloys, ceramics, and other inorganic compounds, even some polymers, substrate, metal, glass, and plastic. Very versatile coating technology. Here, process steps in PVD. All physical vapor deposition process consist of following steps. This is synthetic of coating vapor, vapor transport to substrate, condensation of vapor onto substrate surface. These steps generally carried out in closed vacuum chamber. In this figure, a closely compact vacuum chamber shown here, and all air is drawn out by a vacuum pump. Here, a source and substrate are used, and the melting particle which comes from source, and it is coated onto this substrate. And the source container is heated by resistance heater, and this heater is connected to the electric power for heating. Now, chemical vapor deposition process. Here, two chambers shown here from where a reactant is supplied, and a furnace is used here which is very heated. Two gases are drawn into the chambers. One is process gases and another is precursor gases. Here ammonia, argon and nitrogen are used as process gases, and acetylene ethanol or methane is used as a precursor gases. And by the chemical reaction into the heated furnace, coating is deposited onto the substrate. There are some applications of this deposition processes. It is largely used in integrated circuits, sensors, optoelectronic devices. It is used in coating, generally wear resistance, corrosion resistance, high temperature protection, and erosion protection. Thank you.
Okay, thank you, Sadhan Mandal. It was a really nice presentation, and your slide making is really nice. It's clearly readable and organized very well. Thank you. And do you have any question from audience? I think Himel Roy was the only audience here. Pushpo just came in. Himel, do you have any question?
No, sir.